Good evening. Thanks for being here. Hope you all had some pizza, something to drink. I am, as Sudhir said, Tim, and I run the developer relations team at Startree. I'm going to give you an introduction to Apache Pinot. I have about 30 minutes for that. So why is there a Pinot? It's an OLAP database, like you may know that. I don't want to bury the lead. And it's worth asking, gee, why did we make another one of those? There's a lot of them. Well, there are big things going on in our world, in the world of people who build things out of software. It used to be kind of simple, right? There was a database, it was a relational database, it was the center of your world, you built an application around that database. And the basic architectural paradigm that this borrows from is about 40 years old. It's like almost my age. That's not quite, 80% of my age. And there was a database, you built an application around it, it was easy to think about, you kind of owned the world, it was great. And then suddenly about 10 years ago, 15 years ago, this got a bad reputation. We started calling these things monoliths, and we meant that to be like a bad word, right? And this is a very timely topic because I understand last week Amazon Prime Video said that microservices are bad and monoliths are good. That's what I read on Twitter. So I'm actually going to record a podcast on that on Friday. It'll come out in a few weeks. So shameless plug, Startree has a podcast. It's called the Real-Time Analytics Podcast. If you want to be friends, you should subscribe. In any case, here we are. The monolith kind of became a bad idea. What was nice about it, though, was that application architecture was understandable. Analytics was a solved problem, right? You had a transactional database, and then you moved the stuff into another database. That was all kind of known. And the legacy data warehouse, eventually, that's kind of an old idea. That gave way to data lakes and all of that kind of set of technologies. Essentially the same thing, though, where you're taking this one source of transactional data truth and moving it over here and then running queries on it. And it was understood, it was good, right? We knew how to do that. Now there is a broad consensus that this is still a thing, right? And it's not like you're somehow immoral if you structure applications this way. It is entirely appropriate sometimes to structure applications this way. That was kind of sort of the discovery of that Amazon Prime Video team. If you actually read the blog post, it's a little more subtle than that. Than the hot takes, but there are a couple problems, right? Monoliths didn't handle complexity very well. Software gets big, it's hard to reason about the whole thing. You can't fit the whole program into your head because you're limited in what you can think about. It's slow to test, it's slow to deploy, it can be difficult to scale. There's all kinds of problems there, right? And that way of doing analytics, where here's all the data and every night I'm going to mush it around and put it over here so I can run reports or build dashboards or whatever, put it in the data lake. That is fundamentally a batch process. Over the last kind of 10 years, without anyone really noticing when it happened, that idea of doing batch analytics has become, there's just kind of friction with the way people expect things. And it's a little bit of a cliche, but it's true. I set my phone here for the timer so I can tell how long I'm speaking. But once smartphones became a thing and more and more of our life became mediated through apps on our phone, you actually kind of expect the thing in your pocket to wiggle when something in the world changes. That's just how it is, that you have real-time expectations. And now you, as people who build the systems that cause the wiggles, now you kind of have to build things that are real-time as well, that are event-driven. So there's been this migration to this event-driven world and kind of a broad consensus now that something like Kafka is where events live and to some degree the source of truth at the bottom. And at the top, you've got the actual code you write that takes care of people who buy things from your company or people in the business or whatever. The stuff that, as an application developer, you should actually be paying attention to. Differentiated application code. What goes in the middle? Dragons, right? Because in the world of the monolith, you knew it was a database and fine, pick the language, pick the framework, there's still choices, but you know what it's structured like. With this upheaval, we just don't know what's going on in here yet anymore, because it's now unexplored territory. And when you want from that application code to ask questions about what has happened. Logs are bad at that. Logs are great at, you scan them, right? They tell you the thing that just happened. But if you want to ask questions, now there's all these weird things in the world that people they're not like bad, these are all great solutions, but we're kind of casting about for how to handle this middle section of our infrastructure and answer the question, what has happened, to get insight into what has happened. Because of this upheaval, because of this revolution, this event-driven revolution, which isn't done yet, we're in the middle, we're living through it, there's this weird space. And that is where, I think, why Pinot exists and why real-time analytics has become a thing. So who does this? Well, it started at LinkedIn, and it kind of co-evolved with early Kafka. So Pinot and Kafka have a fairly intimate relationship in terms of typically, like if you've got Kafka in a system and a database, you'll use Kafka Connect to integrate the two. Pinot is a native Kafka consumer, so there's like nothing else in the world as far as it's concerned. It just eats stuff from Kafka. It was designed at LinkedIn to turn LinkedIn from a site I visit once a month when I want to update my contacts or change my resume, or if I'm trying to get a job, to now, I'm probably not a great example. I'm terrible as a social media addict, but it's a site that's worth visiting all the time because Pinot was built specifically to power dynamic features like who viewed my profile, like the feed and all this stuff. There's all kinds of these real-time analytics queries happening just to load a single page. We're going to hear later about, there's a company, I forget what they're called, but they deliver meals and things. And here we are. So we're also going to hear from Stripe. So there's financial use cases, meal delivery. I think it's like maybe only a little bit of hyperbole to say that on planet Earth, if you want to get a meal delivered, Pinot's going to be involved. That might be an exaggeration, but it is only a small exaggeration. So we got meal delivery. All right, I want to talk about how Pinot's built. I don't want to spend, we don't have a lot of time, but I think it's worthwhile if you're new to a technology and the technology is making bold claims like, we're an OLAP database, but we'll do everything in 100 milliseconds, and you can throw 100,000 queries a second at your cluster and everything will be fine. That's a bold claim. If you are a developer using a database, you need to think about tables and SQL queries, right? It's not, that's the kind of the interesting day-to-day using the product in anger kind of interface is it's tables and queries. You don't need to know how it's built, but for me, when I'm approaching a new technology, to properly form a mental model and have some means of evaluating whether the numbers sound like they could possibly be true, I like to look at what's inside. So let's look at what's inside. We're going to start by ingesting data. And the cool thing, kind of the place where Pinot shows up in the world in an interesting way, typically has to do with real-time data and streaming ingest, and like there's probably Kafka or Pulsar or Kinesis or something like that lying around. Trust me, it's a lot easier if we start with batch ingest. We'll get to real-time ingest, but imagine there are giant piles of JSON lying in S3, and we're going to batch ingest that data. Let's walk through the process. So I've got, by the way, it's clickstream data that I'm ingesting. Could be anything. I like the way that looks on the slide, is really why I picked it. Does not even matter what the data is. We're going to ingest those into a table, which, by the way, we will spend zero further time discussing the Pinot data model because it's tables. And the query language is SQL, like you already know how to do it. So I want to ingest those records into that table. As I do that, and again, this is a batch process, so it's reading records from a file, and every once in a while it'll decide, okay, I've had enough, I'm going to write a segment. And then it'll keep ingesting. If there's more data, it'll write another thing called a segment. And a segment, to a first order approximation, just think of that as a file that's got that collection of ingested rows. We break the data up into segments because obviously now we'll be able to replicate these and distribute them among multiple machines in the cluster. We'll talk about how that works in a minute. but this is how Pinot is going to scale storage and compute, by breaking a table up into segments. So all the segments, and those segments make up a table. A table is stored in segments. What does a segment look like? There's an interesting thing that happens here. So because Pinot is an analytics database, it's an OLAP database, it's not a transactional database, that drives some decisions about how data is stored. And if this is a thing that you know about databases, you know it, but if you've never stopped to think about it or never read about it before, this is an interesting insight. So we're going to read a bunch of these and create a segment file, but we're not going to store all of those fields all together. So we don't take this one entity, or just call it a row, because you could turn that into columns and values. We're not going to serialize that whole row together. That's what you do for a transactional database, because often for a transactional database, you're interested in a particular thing, right? You want to change a thing, you want to read a thing, you want to write a thing. It's that entity that is of concern. Usually with analytics queries, there could be certain columns that you're interested in to filter on. Maybe there you could, let's just say you're going to filter, maybe you'll group, and you want to compute some aggregation. What does that mean to compute an aggregation? That means there's going to be something like bytes here. Let's say I want the average number of bytes for all of the IE6 clicks or something. Maybe there's a couple OGs out there, or a couple of diehards out there still doing it. Well, that means I'm going to need all of those byte values, and I want to read them. I want them all in one place so I can scan them. So I want columns stored together. That's what we do. We read this in, and all of the values of the IP column will store those. All of the values of the user ID column will store those. We'll store indexes in the segment as well for whatever indexes we have defined on these columns. And we'll store the columns together. So this is what it means to be a column-oriented database, or a column store. We store the columns together because everything is hyper-optimized for scanning. There's two things that you have to do if you're a database like Pinot, and that's not scan, right? You could scan less, try not to scan something, and scan faster. So that's what's going to drive your performance, your read performance. And so when we're ingesting, this is how we structure the data. All right, so that's a segment. It looks like that. And again, we have lots of these. They're basically kind of going to look basically the same. I'm sure there'll be some little differences between segment to segment for how the values stack up. But we've got all those segments that make up a table. And we'll take away the pretty colors, just give them numbers now. And we're going to put those on a component in a Pinot cluster called a server. Now, I would remind you, naming things is hard. And this is called the server. Now, there are other components which you may also think are also quote-unquote servers. This is the Pinot account of what a server is. It's where data is stored and where most of the query computation takes place. Servers are, in a sense, the true heroes of the Pinot cluster. That's where data is stored, and when queries are executed, that's where they go. So we'll scatter these segments among the servers, and we can replicate. We can define, I want to make sure each segment is stored in at least two places. Segments are immutable, which makes things like replication a little more pleasant, right? We don't have to worry about consensus on anything. We just have to make copies and make sure there's a copy of things, and life is good. Okay, so there's our servers. Kind of building a Pinot cluster piece by piece here. You've seen how we're doing this batch ingest, how we build segments, where segments go. How do we make queries happen? Well, you got a broker. Broker is another unit of the cluster. That's where you send queries, and the broker has access to metadata to know what segments out there will be able to process the query that you are trying to execute. So the broker will then intelligently scatter that query to the servers that can answer it. Those servers will do the I/O and compute, and the broker will gather those numbers back, and they'll go back to the client. You've also got a box called the controller. That's an Apache Helix controller. That's basically, just think of that as doing cluster management. And there's Zookeeper, where the metadata is persisted because everybody loves Zookeeper. So that is a Pinot cluster. And this ingest is happening constantly, of course. So batch ingest, yeah, you've got all that data somewhere, and you're running a utility that is producing segments. That's either a command line utility with open source Pinot, using Startree Cloud. It'll be Startree Data Manager, which you can actually use for free if you really want to. But this is kind of why people come, right? We probably want real-time data and not just batch data. So when we're ingesting streaming data, again, Pinot is its own Kafka consumer, so there's no intermediary, there's no other thing, no connector. It's just, you just hook up the topic, and the fields in that topic will become columns in your table. That topic is consumed and stored into, just think of it as an in-memory data structure called the consuming segment. Now that consuming segment is in memory, and it can participate in queries. So as soon as I have consumed a message, that message can be returned in query results. There isn't any kind of batching or time or anything. Consume it, it's in the segment, you're done. When it fills up, then I dump it to disk and it becomes a segment, and we're going to do that over and over again, right? We'll keep consuming and creating new segments. By the way, you can set a maximum amount of data or time that you want data in segments to stick around, so they can start falling off the edge of the world after 7 days or 10 days or 20 days or whatever you want. Always want to be careful with commercial messages at meetups, but nobody wants to operate this, right? That's a terrible idea. You want to use a cloud service. If you use Startree Cloud, there's kind of cool support for tiered storage, where your cloud blob store of your choice, I think right now as long as it's S3, you can, after a certain amount of time, store data in S3 with some really neat performance optimizations that make it a lot faster than you'd expect. Obviously, there's a latency trade-off, but there's some cool things that happen there that make that go faster. If you would watch our social media feeds and our Slack space and everything over the next couple weeks, we've got a really great video that I did with Neha Pawar, where we're writing on the glass in midair, drawing pictures, talking about Harry Potter. She's explaining how tiered storage works. She led the team that built it, so she's a good authoritative voice on that. Briefly, indexes. I've got some animations, but I'm going to just stick to a list. We're just going to talk kind of about what your options are, right? If you're a database like Pinot, you have to be able to ingest data at a high rate. That's kind of the idea, right? There's streaming data, there might be a lot of events. I sure hope I can keep up and I can ingest those events at a high rate, maybe 100,000, 200,000 more per second, like whatever that might happen to be in a large system. You have to be good at ingesting data efficiently. That's hard. There are engineering challenges there, but in a sense, that sort of gets you into the game. It gets you to the table. It's not really where the money is made. The cool stuff is in reading, right? And again, these are tables like you're used to. To create them, you don't have a create table statement because everybody's sort of vendor-specific extensions to create table has some bizarre options thing that's 600 pages in the documentation and completely non-standard and everything. With Pinot, we just said, you know what? You're just going to write some JSON. Forget it. You don't need to create a table statement. Write this JSON document. And so the table is defined with JSON. There's another JSON document that defines the indexes. Point being, you define the indexes on the columns that you want, depending upon the kind of data that you've got and the access patterns, and you got lots of options. Forward index, I'll leave that. That's kind of, it's common, but it's almost more for internal housekeeping. The inverted index, that's a way of saying, if I know a value, like, what's my zip code? 80120 right now, not for much longer. What are all of the smart thermostats in the 80120 zip code? That's an inverted index kind of use case. I've got the value, and I want to know what the rows are that have that value. There is Bloom filter, which is a nice optimization that helps a server know whether it should bother looking in a segment for something. It's this kind of probabilistic in-memory way of saying, yeah, you should try looking for that, or no, you shouldn't. We got range indexes. I just said smart thermostats, so imagine we've got temperature readings, and I wanted to be able to do queries per degree or something like that. I wanted to break some number up into ranges. I can do that efficiently with a range index. There's a text index that does all kinds of nice things like regular expressions and prefix searches and things you'd expect to do with text. There's a very sophisticated geospatial index, which is helpful probably if you're a company like DoorDash, because you care about the locations of things that are made out of atoms. It is not a purely immaterial business. So that kind of thing matters. That's worth its more than a 25-minute talk in itself. That's a complex topic. There's a great JSON index. I showed JSON being ingested, but you might have a column that's complex nested JSON itself that you don't want to flatten. You just want to bring it in as a blob, as a text blob. Well, you can index that and do fairly interesting kinds of performant lookups inside that JSON structure. There's a timestamp index, and of course there's the vaunted star tree index, not to be confused with Startree. So Startree is the company I work for. The star tree index, you got to say them that way or it's going to be confusing. This is, so now you know, this is an implementation detail that has leaked into the interface. That is how Startree got its name. And normally that's bad, because remember TypeSafe. Remember TypeSafe. What do they call? I remember there was TypeSafe. What are they called now? Somebody see it, right? You don't even know. So they changed that because suddenly strong typing wasn't like the thing they wanted to talk about. In my opinion, I think Startree is a cool enough name. Even when this isn't the coolest index in Pinot anymore, it'll still be a good company name, I think. But it is neat. Basically, if you know pivot tables in Excel or Google Sheets or something, it's like building a pivot table and saving it to disk. If you've got aggregations that you want to return out of the database and 2 or 3 or 4 columns that might be involved in that query, you can define a star tree index and it pre-computes those aggregations, so you get insane performance boosts because it's pre-computed that they look fake. You see the benchmarks and you'll be like, they're lying, it can't be that fast. Well, I mean, there's a story there. And it's a great index. These are pluggable, so you don't even need to rebuild the code. It's all Java SPI stuff. So, new indexes can be developed and plugged in, and probably in 5 years, this won't be the interesting story of the indexes. There will be other things that are there. So that's really the deal. You need to be able to read in the ways that you want, and you get to do that, right? I mentioned pre-computing in the star tree index, but other than that, you're not solving that problem ahead of time. You have to think about your access patterns like any database optimization. You got to know what to index and what your queries are going to be, but you don't have to know everything. It behaves much more like the relational databases we've all been using, and more conforms to those expectations from the API side, from you as a developer using it. It just kind of feels like normal life. And the process of optimizing reads feels kind of more like what you do there, and doesn't push all of that, oh no, I have to completely be explicit about all my reads and pre-compute and throw it a serving layer. With a good set of indexes and a sensible data model, all that stuff kind of gets out of the way. It's great. Anyway, back to the beginning. The work of understanding how to build systems now that we're in this event-driven world isn't done. That is work that kind of we collectively are doing, and exploring, the space with the dragons. The exploration of that space isn't done. But it's my conviction that in an event-driven world, with something like Kafka being pretty much the consensus standard for where events live, something that makes those topics queryable is probably going to be necessary. And something that makes them queryable in real time, meaning fast enough to return a result to a user synchronously in a user interface, is probably going to be a thing that shows its head as a thing that we need to deploy more and more. So I think it's a good thing to know about. And with that, I say thank you. We've got a Slack workspace. You can ask more questions. Take a picture of that, visit that QR code. Thank you.
Okay, hey everyone, thanks for coming to the meetup. It's my first in-person talk in like 3 years now, so I'm really glad to be here. I'm Lakshmi, I'm a software engineer at Stripe, and today I'm going to be talking about building a real-time analytics platform. In this talk, I'll cover how Pinot is used at Stripe today, how it all started, and give you an overview of the user experience. And along with that, also talk about some of the pain points that we have in the whole user experience and what we are building next to resolve those pain points. So before I get started, let's talk about what Stripe is. I trust most of you know what Stripe is. Maybe some of you have used it. But Stripe provides payments infra for millions of businesses across the world. And starting from some of the core payments products, we have a wide suite of products covering risk and fraud detection, point-of-sale terminals, billing, checkout, etc. Pretty much that span the entire spectrum of the fintech ecosystem. So where does Pinot fit into Stripe's wide suite of fintech products? In order to answer that, it's important to internalize that financial data, specifically transactions data, is real-time in nature. And we want to provide our users, we want to empower them with fast, accurate, and fresh data about their transactions so that they can make informed decisions for their businesses. And we actually power a number of user-facing interactions with Pinot today. So if you see this thumbnail here, if you're a Stripe user and you log into your Stripe account, this is pretty much the first landing page that you end up at, which is a home page with an overview of your business's financial health. And this payment widget that you actually see, which tells you how many payments succeeded, failed, is powered by Pinot. Some of those charts are powered by Pinot. Our billing products, which show billing analytics, is powered by Pinot. And Stripe is developer first. So if you're using our Stripe APIs, all your stats about API requests and API errors are powered by Pinot. Aside from all of those external user-facing dashboards and interactions, we also support a number of internal use cases. Our product teams use Pinot for monitoring and alerting on failures in payment processors so that if one processor is failing, we direct you to another. Our financial data reporting team uses it to deep dive into Stripe's transaction data and internal financial health. And we have admin tools to do risk analytics, and we have security tools to look at access logs and monitor them so that we ensure there are no security breaches in our internal services and systems. How did all of this begin? Let's take a step back in time, all the way back to 2021. Our financial data team was doing a POC of Pinot. They wanted to build a query and search platform that would help ingest all of the transactions data and then deep dive into that. They were trying to use Pinot for it. The POC was extremely successful, and they adopted Pinot for that platform. At the same time, in the end of 2021, early 2022, we had another team, the reporting data platform team, using Pinot for a completely different use case to serve user-facing analytics. Some of the widgets that I showed you previously, it's still powered by this platform today. And in that same year, my team, the Stream Analytics team, we own a time series aggregation platform that helps users aggregate both real-time and offline data and serve it through a query layer that transcends that time boundary between real-time and offline data. This might be starting to sound a bit familiar to all of you from Tim's talk, which is kind of what Pinot supports right out of the box. But we were doing this with completely disparate systems, and we ran into a swath of reliability issues. And that's when we decided that Pinot sort of fit this use case perfectly, and we embarked on that journey to migrate our time series aggregation platform to Pinot. And if you're curious to know how all of that migration played out, spoiler alert, it worked pretty well. You can check out my colleague Johan's talk from RTA Summit in 2022. So where are we today? Today, my team owns and manages all of the Pinot clusters that sprung up from different parts of the company and the ones that we brought up ourselves. so that we can provide a unified user experience to the entirety of Stripe. We manage about 8 Pinot clusters in production today. Our largest one has like about 3 petabytes of data. We do 10,000 max QPS, and we run about 120 plus tables in production. This does not like separate out the real-time and offline. Hybrid tables are considered as one. As a next step, let's deep dive into what that user experience looks like. Say you're a Stripe engineer. You want to build a cool user-facing analytics dashboard that ends up in one of those Stripe homepage widgets. You've heard about this cool OLAP system that the Stream Analytics team offers. So you come talk to us, and we ask you a few things about your use case. We first make sure that Pinot is actually the right tool for your product. And once that's determined, we may ask you a few more things. How much QPS do you expect? What's your latency, storage, and freshness requirements? And some of our users actually come from a batch query world where they're querying Presto on a day-to-day basis. So they are actually able to describe what they want to do with their data with simple SQL. And that helps us because we get a sense of the shape of that query that's going to come in. With this squared away, the next question is, which of those 8 production clusters do we put your table or your set of tables on? We offer a few flavors of Pinot. A couple of them are platform-like offerings. The first of which is the time series platform I talked about. It's not just a single Pinot cluster. It's multiple Pinot clusters. They are differentiated by their production tiering. So you can think of it as tier 0, tier 1, tier 2. And for users who are satisfied with the query APIs that this platform provides, and who actually can represent their use case as a time series, and have low latency and high freshness requirements, they're pretty happy with going with this platform. And for users who want to do some of those native dashboard integrations that's already offered out of the box, we also have them using the reporting data platform, which is a single Pinot cluster. And finally, if none of this works for you, we provision a brand new Pinot cluster for your use case. And breaking down some of the differences in those choices there, the time series platform and the reporting data platform, both of them have prepared SQL statements in that they really constrain the SQL that you can write to query those clusters. They both are served by an HTTP API. So you can pass in query parameters, but you can only use those query params to fill your group bys and your where clauses in your SQL. And this is done intentionally because we don't want an arbitrary SQL taking down other production use cases. But if you want to be a little bit more dangerous, we might spin up a new cluster for you to do any kind of ad hoc queries. And we also have predefined interfaces in the platform offerings for pre-aggregating data. The time series platform lets you express your pre-aggregations in Java, and we use that across the real-time and the offline ingestion. The reporting data platform has its own DSL to describe your pre-aggregations. We support all kinds of tables on the time series platform. We only support offline tables on the reporting data platform, but that's soon going to change. As we speak, we are experimenting with real-time tables. And the time series platform gives you the strictest guarantees in terms of freshness and latency requirements. With the reporting data platform, the freshness is in the order of hours because today we only support offline tables, but that's soon going to change. Okay, so now you know which cluster your table should live in. The next step is to get data into your table. If you have a real-time component, you typically set up a Kafka topic. And if your aggregations, you mostly pre-aggregate data because that's sort of the best of both worlds you get, where you pre-aggregate some data into time buckets, and that way your queries are faster. Simple pre-aggregations like sum, max, and counts are supported in Pinot natively using ingestion pre-aggregations. If you need to do something more complex, like you want to actually join 2 Kafka topics before you ingest it into Pinot, you want to union them, users usually end up doing that work in Flink, and that Flink outputs that data into a Kafka topic that Pinot can then automatically pull from. On the offline side, we have Spark jobs doing the same pre-aggregation and uploading segments into S3. And all of these Spark jobs get orchestrated using Airflow. We have scaffolding and templating to make this happen so that you don't have to write like tons of code to generate your Airflow tasks. We use some Airflow decorators to make this happen. And with this, the responsibility of the user ends, and they pass on the work to our team, and we start creating all the required resources. It starts with deploying our streaming plugins, because the way this works is, if you're going to do pre-aggregations, all of that work has to happen on Pinot's real-time servers. And to know what pre-aggregations to do, the code where you describe your pre-aggregation actually has to be deployed to those real-time servers. So we deploy those plugins, and secondly, we restart the cluster so that it actually picks up the deployed plugins. We restart the cluster using a control plane so that we maintain 100% query availability during the restart on all tables on that cluster. And then finally, we create your tables, schemas, your tenants, and your configurations using a CLI tool. At the end of all of this, you now have a table. You have data streaming into the table from both the real-time side and the offline side. So you're ready to prod. As a first step, we move to a QA environment, and users usually do functionality testing there. They might change the schema of their table. They might experiment with other queries. And finally, once they're satisfied with their iteration, they're ready to roll out to prod. And what this rollout, we've done different ways of rollouts. Sometimes when we did the migration, we have done shadow rollouts where we have an old system and a new system that's backed by Pinot, and we sort of shadow queries to both the systems. We also do slow dial-ups of our queries from 0 to 100%. The reporting data platform team has actually a way to promote dev tables to production. So whatever rollout you choose, you now have a table in production that you can query either using the platform APIs or directly by querying the Pinot brokers. Now you're done, you're querying the table. You might have questions about, is my table actually okay? How are my queries performing? Are you giving me all the guarantees that you promised when we started out with this? So we have comprehensive observability to answer all of those questions. We have dashboards that monitor all of our system metrics for the Pinot servers, Zookeeper, brokers. And we also alert on ingestion lag so that we don't compromise on freshness for our customers, replica unavailability, segment health, query latency, and any ingestion failures on the data ingestion jobs are also something that we get alerted on. And finally, as a platform team, we provide freshness, availability, and latency guarantees for all of our users. Okay, all that's great. Where do we go from here? To get to that, we need to tease out what the pain points of this current user experience is like. Firstly, the user onboarding workflow is fairly manual. Users have to come in, talk to us. We figure out which cluster their table lives in. And most of the times, users actually need to know which cluster to invoke their queries to. And there's way too much internals being exposed to our users. They need to figure out how to generate those table configs and the table schemas. And we want our users to be users and let us be the Pinot experts as much as possible. And for users who are not really used to the data platform ecosystem, they also need to know how to manage Flink jobs, Spark jobs, Airflow tasks, and the whole world of those kinds of infrastructure. And for our team, creating the resources is fairly manual. We have to execute a sequential number of steps to create the tables, restart the clusters, and operations like scaling up and down the cluster is toilsome. We still run on bare metal EC2, so spinning up and spinning down EC2 machines has a long tail. So when we started thinking about what should the next gen platform of Pinot look like at Stripe, one of the things that we wanted was when a user comes to us and says, I want to use Pinot, let them talk to a service. Let's remove the human out of the loop, and let's make that onboarding more automated. And instead of giving us in writing what their requirements are, let's encode that into an actual API contract where you tell us what are your QPS requirements, what are your freshness requirements, and we use that information. Firstly, we store it, and then we use that information to create the appropriate resources. Maybe we direct you to tenants that are in tier 0 because your freshness requirements are like really high. And once we create the resources, all of these creation workflows report back a status to a database, and we actually have a well-known state of our tables and clusters and tenants at all times. And the other core design tenet that we want to achieve is that users should not have to know anything about a Pinot cluster. All that they should worry about is the tables and their queries. And this will help us in the future if we ever wanted to say, merge clusters, split clusters, or swap them out underneath. This is a completely transparent operation to the user. And to that end, we want to build a unified query API that would then abstract away the cluster from the user and know which clusters to route their queries to. All of this is in like different stages of development, some of them being designed, some of them being implemented. And so to put that all into words, for all of our new use cases, the model we want to go to is use a single shared cluster with tenant isolation. Pinot already has a concept of tenant and tags, where you can isolate all of your servers, brokers, by tenant tags such that you're able to isolate the workloads as well as the storage. And secondly, we want users to only care about tables and not the cluster. And user onboarding is less human in the process. And they're always able to know the state of their table, whether it's ready to be queried, whether the ingestion has happened. And for our team, the resource creation is more automated, and operations like scaling up and down is more automated and more observable. And last, but in no way the least, one of the greatest things about working on this team and this project has been engaging with the Pinot open source community. So we want to continue to contribute to and learn from this community as we make Pinot generally available at Stripe. So that's my talk. Thank you.
Thank you. Cool. So yeah, the contents of this presentation. So my goal will be to walk through the example use cases we have here at DoorDash and optimizations we made to ensure that they scale properly. In particular, the two use cases I want to cover, the first one is the MX Portal ads campaign reporting. That's a customer-facing use case that shows DoorDash merchants how their ad campaigns are performing. And the second one is risk platform dashboarding. This is an internal use case which helps one team in particular, our risk and fraud team, visualize their platform metrics in real time. So sort of similar to the Stripe use cases. Before I get into that though, an overview of Pinot at DoorDash. We have a single cluster with 3 controllers, 21 brokers, and 58 servers. It's multi-tenant, so we use like the tenant feature Pinot provides, and we currently have 18 corresponding to different use cases. The single cluster definitely has some trade-offs as opposed to running multi-cluster, but for that we deploy on Kubernetes with Helm. Helm provides like the chart that you can use to spin up resources, and to kind of support like different tenants, we use multiple Helm releases to provision resources for like a tenant specifically. For the customer-facing use cases, we have multiple, but they all go through like a single UI, which is the MX Portal. I'll talk about that a bit more shortly. And internal analytics use cases, they mostly revolve around dashboarding performed by our product and operational excellence teams. And most of that is motivated by the real-time ingestion capabilities of Pinot, as well as low query latency. Cool. So the first use case, MX Portal ads campaign reporting. Yeah, so the product behind this, the DoorDash MX Portal, MX is short for merchant, shows merchants how their business is performing. So this can be things like, how many orders did I get today, or like which menu items are popular. And one feature that is there in particular is the ads campaign reporting tab. And so DoorDash merchants can run ads, and that shows up when like consumers like me order. And this tab in particular for merchants who run ads, it shows their conversion rate. And so like kind of the life cycle of an ad is like there's an impression or like a view, and then a user may or may not click on it, and then they may or may not make an order. And so yeah, here on the right you can see kind of what this looks like. And in Pinot, what this translates to is 3 hybrid tables. They're called, in this case, ad view, ad click, and CPA, corresponding to the impressions, the clicks, and the orders. As you can see in the right, in the Pinot tables page, the size of the ad view table is obviously the largest. The size of the ad click table is going to be quite a bit smaller, and the order table is going to be even smaller than that. But yeah, the reason why we went for this hybrid table approach is the real-time table provides minute level freshness and whatnot. But we found that the offline table generally provides more stability, as well as you can do some post-processing such as deduplication if you want. So that's why we have that hybrid table set up. And what the queries look like from the MX portal. Typically what they do is like we're interested in a single merchant business or like a store corresponding for that business. So there's going to be some like where filter and they want to aggregate like metrics such as the sales or like, in the case of just the impressions, it's just like a count query. And in terms of like the indices that we use, we use an inverted index for this because typically for like a merchant, there's only a few number of rows. Like you can think like in orders, how many orders is a merchant going to get a day? It's like probably in the number of like hundreds or maybe thousands, but not too much more than that. So in our case, we thought the inverted index was perfect. But for heavier use cases, I could see why you'd want to use like, for example, the star tree index. And so that was all like good and dandy when we first set it up. But one problem that we ran to as things scaled was that as the data volume grew, the number of segments in the table grew. But that also meant that the queries for like a business or store had to essentially read more segments. Pinot publishes Prometheus metrics, and so here's one that kind of corresponds to how many segments are being like processed or read. And there's kind of like a periodic trend to it, so it's hard to tell, but it kind of goes from around 400 to closer to 1,000 over the span of a few months. And this contributed to a few latency issues we were seeing with the product. The solution for us involved a key fact, which is a query only involves a small number of rows because it only corresponds to like one store or business at a time. And like that number of rows is going to be in the thousands, and that can entirely fit onto one Pinot segment. So theoretically, there shouldn't be a reason why we're scanning over or reading a bunch of Pinot segments. The reason that happened though was in the beginning, we didn't make any effort to make sure that all the rows for like a business or store was on one segment. And so the solution was to co-locate them. All data in Pinot is of course time-based, so it's going to be like for a single date or a single date partition, the segments that correspond to that, you're going to try to co-locate the rows for that, just one partition. And how we ended up doing this was through sorting the rows within a date partition by their store ID. There's different ways you can kind of do this in Pinot. You can do like partitioning, like people do like, like modulo and stuff like that. But sorting worked well for us, and it's relatively easy to do because when you're exporting data to Pinot, you can just add like some order by statement, and it does it for you. Cool. Another problem that we kind of ran into, also as data volume grew, was that we saw increased disk reads. This was particularly the case. As I mentioned, the tables are hybrid, so there is that like data load that happens daily for the offline table. And during those offline loads, we saw our latency go up. And yeah, that was also due to the disk reads. So kind of like some more context on that. In Pinot, segments are memory mapped. So when they aren't in memory, they need to be paged in. And a little bit of paging is fine. But if you're reading a lot of segments from disk and you're having like, hundreds of queries per second, you're going to see high latency. And so the solution for this problem was while data loads was what kind of caused the spikes in our latency, we realized that a contributing issue to this was the fact that the real-time table was using more memory over time. And it was using more memory over time because that's also like a consequence of the increased data volume. And the graph at the bottom kind of shows it's also kind of hard to see, but we're using more memory over time. And so what we did to solve this was to separate real-time and the offline servers so that like the real-time table is on one set of servers and the offline table is on a different set of servers. And that change actually had a like significant improvement on latencies. So yeah, this one was definitely very important. Cool. So yeah, that's a little bit about the merchant portal use case. I'm now going to talk about the risk platform one. So yeah, basically we have a risk or fraud team at DoorDash, and they own a platform to determine things like bot signups. And internally, they wanted to monitor the metrics on their platform in real time. And so Pinot was like a perfect kind of candidate for that. And what they did was they ended up building dashboards in Superset on top of Pinot tables. And yeah, some example tables kind of looks like this. They also went with a hybrid approach. The tables contain like metric or event data that they're interested in. And then the queries from Superset, what they'll do is they'll just aggregate these metrics. It might look at like a slice and dice. It might look at a specific dimension, and it will do it over like different time windows and granularities. So yeah, one kind of interesting thing about this is, so these are like charts in Superset. So you might, like one chart might be like, oh, the past hour, one chart might be the past 7 days. And in each case, like the data points that you're plotting at are a little bit different. So like for the hourly chart, it might be like, minute level plot data points. But for the 7 days one, it might be like just hourly or daily. So what we kind of realized was like in Pinot, you have like a time column, but that time column might not be good for graphing at different like granularities. So we created multiple time columns so that that query in Superset was sped up. And so it's you're kind of doing a little bit of like pre-computation or pre-aggregation a bit. Cool. But yeah, the main thing I wanted to talk about with this use case was like kind of optimizing its resource usage. So while Pinot provided value to the fraud and risk team, due to the table volume, it required like 6 servers to host, and that was a bit much. But kind of like one key fact here was the team was most interested in like the recent days data, even though the full table might have had like 90 days worth of data. And so we were able to kind of resolve the high resource utilization issue by onboarding to tiered storage. And yeah, this reduced our server count to 2 from 6. And you can kind of see on the right, like the instance count and showing the number of segments on each server. And then the first one is the tiered storage servers. And those are actually pulling from S3 when they query the data. Cool. So yeah, in conclusion, Pinot is a great technology that has allowed DoorDash customers to receive analytics in real time with sub-second query latencies. But to ensure that the performance has been good as we scaled, we found that both our users, so like the product teams, as well as us, need to be aware of details such as how the data is laid out, and as well as things like memory and disk usage. On the internal analytics front, Pinot can provide snappy dashboards with sub-minute freshness. But one thing we're thinking about is like the speed / resource cost trade-off, because these things do require servers to host. So that's something to consider. Cool. Thank you for listening.
For the superset interaction, and that's mainly going to the product team that's interacting with that then?
Yeah.
Do you find, are there often questions coming in of a chart or visualization or some sort of calculation that the current table structure is unable to answer? So I mean, you talked a little bit about hey, we pre-calc or pre-truncate the timestamp in order to get performance. What about other dimensionality? Is it always just a timestamp on the x-axis, or is there other kind of slicing or dicing that they're trying to do that you're kind of limited by on the Pinot data model?
So I think mostly it's been like the timestamps that have been the issue. I think sometimes people, they're like Kafka topic, like the data is in like some JSON format. It's like not flattened. And so they need to have like either a Flink job or like an ingestion transformation in the Pinot table to like flatten out before they have that, before they create that dashboard in Superset. But so far, I don't think we've run into any things. Yeah.
I was curious about one of the problems you mentioned about growing data sets, especially for real time, and how that caused degradation overall. Do you see any other problems with growing data sets, and is data retention on your mind a strategy for deleting older data? Is that something that your team is actively thinking about?
Yeah, so on like data retention, so like a lot of kind of like the product teams, they want to say like, oh, we want our customers to be able to query like anytime in like a 5-year window. And while that's really cool, like in terms of like a product feature side, like it's a little more challenging because when you like, enable this huge data ranges, like you have to store more data, but also like, querying like data that hasn't been accessed recently will pull it from disk, and that might be a little bit slow and stuff like that. So far we've kind of been talking with our product teams, like say, what if like for data in the past, you have like a separate table that's actually aggregated, so it's a lot smaller and stuff like that. But we've definitely like tried to like draw the line where like, we can't have like this much data, or else you're gonna see performance problems too in your product.